Trigonometric equations involving compound and double angles. Let's have a look at the double angles first. Here's our first example. Yes, you see there we have a cos 2x and a cos x in the same equation. This cannot work, so what we do is we treat it the same as in identities. We see the double angle as the complex one. So therefore we're going to reduce the double angle to single angles. I didn't say reduce to cos, it could be sine as well. And that's where our problem is, of course. Remember that there are three options open to you for cos 2x. Now we need to decide which one. Well, cos squared minus sine squared is going to be no good with cos, nor is sine squared going to be any good for you with cos. So therefore we know we have to use the middle one. So we are going to take that 2 cos squared x, we're going to put it in place of the cos 2x, and we end up with this here. Now we can rearrange the equation to get it in a factorizable form. Notice it is a quadratic trinomial, which hopefully factorizes into 2 brackets. If it doesn't, then you'll need to use quadratic formula. Yes, 2 brackets, there we are, which gives us cos x equals a half and cos x equals -1. Cos x equals a half, well, that involves special angles. I hope you remember cos of 60 is a half. That does make life easier than having to use the calculator the whole time. Cos positive, therefore, first and fourth quadrants. So there we are, 60 plus k360 and 360 minus 60 plus k360. As far as the -1 goes, we must think of the cos graph. It goes from 1 down to -1 and then back up to 1. So at -1, it's only at -1 at 180 degrees. And then it repeats every 360. Therefore 180 degrees plus k360. K element of z. If we look at this next one, a fairly similar one, once again we need to consider, and I think it's going to be very clear immediately which one we're going to have to use. We're going to take 1 minus 2 sine squared x, and we're going to put it in place of cos 2x. There we are, like that. And we're going to have to do some sign changing, because I don't think that you should try to factorize a quadratic with a negative on the x squared term. So there we are. That sorted out a few signs and got it in the right order. Factorize into 2 brackets. Gives us sine x equals -1/2 and 1. Well, once again, this is a special angle. Sine of 30 is a half. Negative means third and fourth quadrants. So therefore we're going to end up with 180 plus 30 and 360 minus 30, each plus k360, k element of z. For the sine x equals 1, think of your sine graph. It starts at 0, goes up to 90 degrees. There we are at 1, and then down again to 0. So it's only at one point 90 degrees, and then every 360 degrees after that. 90 degrees plus k 360 degrees. Simplifying, there's our answer. Next one. 3 sine 2x plus 4 cos x equals 0. Well, this shouldn't be a problem. We know that there's only one expansion for sine 2x. That's our 2 sine x cos x. So there we are. There, you'll notice I've actually divided through by 2. There's a 2 factor. There's a 2 factor there. So therefore we've divided through by the 2 to simplify the equation. Now, while that's not a quadratic trinomial, that's of the quadratic equation sort where you need to factorize, common factor of cos, and we have cos multiplying the bracket to give you 0. So either cos is 0 or the bracket is 0. There we are, cos x is 0, and that gives us 90 plus k 180. Check the graph, you'll see it. And then for the 3 sine x minus 2 to be 0, it means that sine x is 2/3. Sine positive, first quadrant, second quadrant, so we're going to get the key angle, and 180 minus the key angle. There we are, key angle, 180 minus the key angle, plus K360. Note I haven't written K element of Z. We already have it here. We don't need to have it again in the same sum. And there are answers. Here's some examples, just 2 examples for you to try. Pause, try them yourself first, then I'll go through them. Right, let's go through them. This one, expansion, well, only a single expansion, 2 sine x cos x minus sine x. Take out a sine x, 2 cos x minus 1 equals 0. That means sine x is 0, or the bracket, 2 cos x minus 1 is 0. Give you sine x 0, or cos x equal to a half. This one, if you think of the sine graph, starts at 0 up and then back to 0 at 180 and then back to 0 at 360, every 180 degrees. There we are. So therefore, x equals k 180 is your solution for that one. Cos x equals a half. There we are. That's a special angle, 60 degrees, first and fourth quadrants, plus K360. We have our K element of Z on that side. Simplified. Next one. Well, this is the cos 2x and then cos x. We need to make that decision. There we are. One of the 3. Well, we have a cos, so therefore we're going to have to choose the middle one. There we are. So we're going to slot that middle one into the equation, simplify the equation, factorize, solve. Oh, we get cos x equal to a half again, and 1. There we are, 60 plus K360, and 360 minus 60 plus K360. And K360, because it starts at 1 at 0 and then it's only back again at 360 degrees. So every 360 degrees. Right, now we're going to look at equations involving compound angles. Here's the first example. Now I hope you can see a pattern. Cos sine, sine cos. Well, not quite the pattern you used to. You used to sine cos, cos sine. Well, that can be written as sine cos, cos sine. And that is, of course, the sine expansion formula with a plus, because remember, sine by its name is careful about its signs, so it keeps them. So therefore, we know that this is sine of 40 plus x, and it's equal to 0,5. Now we're going to solve for x, but we have to eliminate the sine first, because sine is very selfish. It won't let go of the angle. Remember, when we do this, when we eliminate the sine, we have to get the full general solution with quadrants. There we are. X plus 40, or 40 plus x equals. Sine of what is 0,5? Well, it's 30 degrees is the key angle. First quadrant, because sine is positive. Second quadrant, 180 minus 30. Subtract 40 from both sides, so that becomes 30 minus 40 minus 10, 150 minus 40, 110. Notice we have not subtracted from K360, they're the unlike terms. Right, another one, similar thing. Have a look. Cos, cos, sine, sine. Cos 3x sine, cos 2x sine 3x sine 2x. Oh, that's the cos expansion pattern. Of course, remember, cos is not sine, so therefore it's not careful about its sign. So therefore, this is the expansion for the minus. So therefore, we have cos of 3x minus 2x equals 1. To solve this, we must get general solution, because cos is selfish, so we have to eliminate cos by getting a general solution. In fact, 3x minus 2x becomes x. So So therefore that makes it straightforward. There we are. X is K360. We've already talked about that before. Yo. This is a tougher one here. If it was a 0 there, we could do that very clever move of moving root 3 cos x to the other side, dividing by cos x, and having tan x. But this one is not the case because of the 1 there. But now there's a 1 there, and there's a root 3 there, and there's a 1 there. And if you think about it, in the special angles, we have 1 over 2, root 3 over 2. What I'm going to do here is I'm going to take that equation and I'm going to say, well, hang on, root 3, that reminds me of something. Think of root 3 over 2. Yes, yes, yes. So I'm going to divide through by 2. Each of those I'm going to multiply by a half. So there, half sine x, root 3 over 2 cos x equals a half. There are special angles. Now you can either choose this to be cos of something or sine of something. I'm going to choose it to be cos of 60. And I'll choose that therefore to be sine of 60. So there's our sine cos, cos sine pattern. Sine expansion, so therefore sine of x plus 60 degrees equals a half. Get rid of the sine, x plus 60 equals sine positive, first quadrant 30, second quadrant 180 minus 30. Subtract the 60, negative 30, 30 minus 60, and 150 minus 60. So there we are. Some examples for you to do yourself. Pause, try them. Answers to follow. Right, let's have a look at the answers. This first one, well, 1 across, let's hope it factorizes. Here we are. Yes, that one will factorize. 5 cos x plus 1, 3 cos x minus 1 equals 0. Therefore, cos is negative 1/5 from there, 1/3 from there. Solving for negative 1/5, where is cos negative? Second and third quadrants, 180 minus, 180 plus. That's 0,2, so we go shift cos 0,2. Remember, don't enter the negative. The negatives told us the quadrants. There are our key angles, and we simplify. Cos x equals 1/3, well, that's positive, therefore we know it's first and fourth, so therefore key angle and 360 minus key angle, plus k 360. And simplify. There's a k element of z there, but it isn't necessary because we already have it there. But if you write it, it's fine. Next one. Alright, we know there's a sine x there. We have to make a decision with cos 2x. Well, if there's a sine, that can only be written as 1 minus 2 sine squared x. There we are. And I've simplified it to the quadratic 6 sine squared minus 5 sine minus 6 equals 0. Luckily it does factorize. This gives you sine x equal to 3 over 2, and that gives you sine x equal to negative 2/3. But hang on, 3 over 2? No. Sine has a range of negative 1 to 1. Sine cannot be 3 over 2. So, if we have a look at this, sine is negative. Which quadrants? Third and fourth, 180 plus, 360 minus. Key angle for 2/3, 41,8. Don't enter the negative. The negatives told us the quadrants. The calculator will get clever and give you an answer for negative, and then you'll add it to 180 and you'll go wrong. Simplifies to that. Next question. What is happening here? Sine squared, sine cos, cos squared. Now, we could factorize into two brackets, because it's like having 4a squared plus 7ab plus 3b squared, and you have factorized those before. But here's a hint for you. Divide through by cos squared x. So we end up with sine squared over cos squared. That rings a bell. Sine cos over cos squared. Well, think that cos cancels with one of these, give you sine over cos, and cos squared cancels. Yes, it gives you that. 4 times sine over cos, all squared, plus 7 times sine over cos, plus 3. Sine over cos, tan. So 4 tan squared plus 7 tan x plus 3. Factorizes. That gives us tan equal to 3/4. That gives us tan equal to -1. There we are. Now remember tan, and I'm going to do it this time because I'm naturally lazy, I'm only going to do 1 quadrant plus k180. You don't have to do 2 quadrants plus k360 because tan's quadrants, when positive, are separated by 180 degrees, exactly, and same as when it's negative. So there we are. Key angle, 36,9, where's tan negative? Second and, never mind the and, second. 180 minus 36,9 plus k 180. There it is. -1, also second and fourth quadrant, so I'm going to go for second plus k 180, and special angle 45 degrees. So there we are, 180 minus 45 degrees. So we have 135 degrees plus k 180. Let's have a look at the next one. This looks terrible, but in fact, hopefully you're in the habit of knowing that if nothing else, you must first reduce these angles, 113 and 203. So 113, I'm going to say, is 180 minus 67. So it's still 113. I'm going to say 203 is 180 plus 23. Still 113, but now sine of 180 minus 67 is second quadrant, sine positive, therefore sine 67 cos x. Sine of 180 plus 23, third quadrant, where sine is negative, so we have a negative here, sine of 23. I'm going to say it again. Remember that 180 plus 23 and 23 are not the same angle. They have the same sine value except for the negative because of their xy-r's. Same with 180 minus 67 and 67. They are not the same angle. They have the same trig ratios except for positives and negatives. Now, this is fine, but you see, we still don't have, I was hoping for a sine cos cos sine or a cos cos sine sine, but have a look at 23 degrees and 67. Do you notice something about those? They add up to 90. So that's quite convenient because we then have our co-ratios. So instead of sine 67, I can write cos of 23. Now have a look. Cos 23, cos x, minus sine 23, sine x. Cos cos, minus sine sine. There's the pattern. Cos of 23 plus x equals 1. Which means 23 plus x equals k360, because that's the value. That's the value for cos x equals, cos of theta equals 1. Subtract 23 degrees, and there it is. You could have written this as 337 degrees plus k360 if you like, but that's fine as it is. Number 5. Sine x plus cos x equals 1. Or here our hint, divide by 1 over root 2. Right, we're going to take that. If we divide, you see that's 1. So it's over root 2. That's 1 cos x, so we put it over root 2, and we put that over root 2. 1, 2, 3 terms, all divided by 1 over root 2, or multiplied by 1 over, divided by root 2, or multiplied by 1 over root 2. Now we should recognize that. Strictly speaking, that's the same as root 2 over 2. And you need to know that. You need to remember that. Because root 2 over 2 comes from a special angle, sine or cos of 45 degrees. So now I can choose. And because there's a sine there, I'm going to get a cos there. So I'm going to say cos 45 sine x plus sine 45 cos x equals 1 over root 2. Or root 2 over 2. If you enter 1 divided by root 2 on your calculator, it'll give you root 2 over 2. There's your sine addition, x plus 45 degrees. First and second quadrants, because sine is positive. Therefore, we're going to say x plus 45 equals first quadrant, second. Subtract the 45, and there we are.